Hello, everyone. Welcome to lesson 512, day one. Our goals today, we want to take a look at the different representations of functions, such as our tables and our graphs, and we want to understand what kind of impact or what kind of relationships exist between a function and its inverse in the table and the graph. All right, so we're gonna learn how to graph the inverse of a function today, and we're also going to learn how to create a table for the inverse function to go along with its equation, right? And then once we have those things built, we want to be able to identify the relationship between the graph of a function and its inverse, as well as the relationship between the table of a function and its inverse. All right. So let's start with a really simple function. This is just a simple linear function. We have 2 times x plus 1, right? So f of x is 2 times x plus 1. And what we learned in the last 2 lessons was how to verbally describe this. So I'm going to write my instruction manual here. So I'm going to say step 1 here. The first thing they did to x was they multiplied by 2. Right, and then the second thing that they did was they added 1, right? So we multiply by 2, then add 1. So this is my instruction manual that describes what our original function does. Now I want to do the verbal description of the inverse so I can write its equation. All right, so remember we start with the last thing that was done and we undo that first, right? So step 1 of my inverse is going to be subtract 1. Right, and then I have to undo this one, so we would work our way backwards. So there's only one step to work backwards to, so that would be this one. So we're going to undo a multiplication by 2, which means we're going to divide by 2. There we go. All right, so now I have my instruction manual for my inverse. So I'm going to come over here and I'm going to write my equation. So I'm going to put my x in there, and I'm going to say, okay, the first thing I need to do is subtract 1. So I'm going to say x minus 1. All right, and then it wants me to divide by 2, so I'm going to say x minus 1 over 2. All right, so there is my inverse. All right, so now I have the original function and I have the inverse. That's what we practiced over the last 2 days. Now we're going to take it a little bit further and we're going to build a table for the original function, and then we're also going to build a table for the inverse function. All right, so let's start with our original function. I'm going to use my calculator here to help me out with building the table. It's a lot faster than trying to build it by hand. Okay, so you want to hit that y equals button on your TI-84 calculator. Hopefully you got access to that. If not, there's a link in the course information page where you can find the download for the TI-84. It'll look very similar to this, and all the key pushes will be exactly the same. All right. So here we go. I've hit y equals and I entered in my original function, and I'm going to go right to the table. So I'm going to hit second graph, and I'm looking at my table that I have here, and I'll make that a little bit bigger for you. Okay. And we can actually just start right where the table starts off. I'm going to go from -2 to 2 and just grab this part of the table and put it into my notes here. So I'm going to say -2, -1, 0, 1, and 2, so we'll use those inputs. And then let me go back here and get some of these values, right? So we had -3, -1. And then we had 1, 3, 5, right? So 1, 3, 5. All right, so there's my table. And what this tells me is when I put a -2 into f of x, we do stuff to it, right? This is the stuff that we do to it, and out comes a -3, right? So input, output, we put a -2 in, we did this stuff to it, we got a -3. Now remember, what an inverse does is it goes backwards, right? It undoes everything we did, right? So theoretically, I should be able to take this -3, input it into my inverse function, right? So the -3 would become the input of my inverse function, and theoretically, it should take me back to -2. Let's try it out real quick. So I'm going to take a -3, I'm going to put it in here for x, right? So we got -3 minus 1 over 2, right? So let's do this in order, right? First, we're going to subtract 1. -3 minus 1 is -4. And then we're going to divide by 2. So -4 divided by 2 is -2. So sure enough, when I put the -3 in, I got a -2 out. Let's see where we can see that on the calculator as well. So I'm going to bring up my calculator here. Put it right here for right now. So I'm going to go ahead and put my inverse function into the calculator. So I'm going to go y equals, I'm going to clear out the original function, And to make sure that I get my inverse function right, I'm going to put the top part in parentheses. And this is really like one of the frustrating things about the TI-84 is you have to be careful with those parentheses, otherwise it won't do fractions correctly. All right, so this is how we want to input those types of functions that we see into the TI-84. So once I have that entered, I'm going to hit second graph. I'm going to go back to my table here. So remember, our input was -3. So I'm going to go to -3 here, and notice my output is in fact a -2. All right. So what I'm going to do is I'm going to take all of these outputs that we got from the original function, and I'm going to use them as inputs for my inverse function. So I got -3, -1, 1, 3, and 5. All right. So all the outputs over here became the inputs over here. And then I'm going to go and find these results from my calculator and see what happened. Okay, so -1 became -1. Okay, and then we have 1 became 0. Right, so we put a 1 into our inverse. It took us to 0. And we do the same thing for the 3, right? So 3 went to 1. And then for 5, right, I go down here to 5, and it looks like I got a 2. All right, so if I'm looking at those tables, right, so this is my original table for f of x, and this is my inverse table. What do we notice that happened here, right? If I look at these inputs and outputs, it looks like they just switched places, right? They kind of flip-flopped, right? The -2 and the -3 became -3 and -2. They flip-flopped. All right, so that's definitely a relationship that we want to keep in mind for later. Like, it is actually really easy to build an inverse table because all you have to do is take the inputs and outputs of your original function and flip them to get the inputs and outputs of your inverse table. All right, let's take a look at the graph. We're going to start by graphing these points and seeing what we get. Right, so let's see if there's any kind of cool relationships on the graph. So we got -2, -3. I'm going to plot that point. -1, -1, 0, 1, 1, 3, and 2, 5. All right, so we got all those points plotted, and I'm going to draw a line through that. So let me get my line tool going here. There we go. So I got my line plotted. That is f of x, and I will label that so we know which one is which. And then I'll switch colors here, and we'll graph the inverse and see what that one looks like. Let's go with green. And now we're going to plot these points, right? So we're going to go -3, -2. So we'll have a point right here. It's kind of hard to see. Let me get a different color. Get a different color there. We can go with like a darker green, maybe. That's better. All right, so we got -3, -2, and then again we have -1, -1. So we have a point that kind of falls on the old line there, and then 1, 0. Located right here, 3, 1, and then 5, 2. All right, so you see our line forming there. So let me grab my line tool. I'm going to plot that line. And of course, you can do this on your calculator too, right? Because you can just go to your TI-84 and put this one in Y1, put this one in Y2, and graph those simultaneously. I'm just doing it by hand because I think it's valuable to see how to do some of these by hand at least once, and then jump over to technology and see what that looks like. All right, so here we go. So here's our graph. Really nifty graph. It might not be extremely obvious because we're looking at lines, but there is a relationship between these two lines. When we look at the graph, there's a bit of symmetry going on in the graph, right? And I know it might be a little bit difficult to see, but the next graph that we do in this set of notes will make it a lot easier to see that. So I'm going to graph this in a nice visible color, but I'm going to show you where the line of symmetry is here, okay? Goes right down the middle. Now remember, a line of symmetry is a line such that if you were to take whatever is on your graph and fold, you would get one side that lands right on top of the other side. Okay, so our line of symmetry is right here following these points, kind of splitting that graph in half And if I were to take this side of the graph and fold it over this line, it would land right on top of the other side of the graph. That's a demonstration of symmetry there. You know, it's kind of hard to show through a video, but this is a really peculiar relationship, is that we have this symmetry that exists between f of x and its inverse. All right, let me label that other line real quick for you so we can keep that consistent for our notes, right? So this green line was our inverse. Original, inverse, symmetry. All right, so let's jot some of that down. All right, so what did we notice about the tables? We noticed that the inputs and outputs flipped. And then what did we see? That's a typo. That should be, what did we see in the graph? All right, so we're trying to recognize these cool things that happen when we got these things in the same table in the same graph, right? So what did we see in the graph? We saw symmetry, right? So, and specifically over that pink line. And that pink line has an equation, right? So you want to remember this. The line of symmetry that we saw in this graph happened at the line y equals x, right? If I graph this line, we would see this symmetry, all right? Now I want to show you that on the calculator real quick. So let's see what that looks like on the calculator. Okay, so I already got my inverse in there. I'm going to put the original function in there, which was 2x plus 1. All right, so now I have the inverse and the original function in there, and I'm going to go ahead and hit graph. All right, so we can see it should look very similar to what we got here when we graph by hand. And it does. Right, so we see almost the same graph. And then I want to show you the line of symmetry. Okay, so I'm going to go here to y equals. And remember, I told you the equation of the line of symmetry that we found in our graph was y equals x, right? So all I have to do is hit y equals x here, and I'm going to put that into y3. Right? So there we go. So I put that in there, hit graph. Now watch where that line goes. See how it splits it right down the middle? That is our line of symmetry. Let me make that a little bit bigger here for you. So you can see there's our original function, right? There's our inverse. And this black line right here, that is our line of symmetry that exists between the two functions. Okay. All right, let's do one more here. With this one, I am not going to make you find the inverse. I've already given you the function and its inverse, and I already graphed it for you over here, so it'll go a bit quicker. And I really like this graph because you can really see that line of symmetry. You can see where the symmetry exists with a graph like this. It's a little bit more obvious than just having those straight lines on the graph, all right? So let's put that line of symmetry in there, right? We should notice that right away from the graph, right? So this, this green function and the red function, right? The red function is our original function, f of x. That is the one that is described here. The green function is the inverse. This is f inverse of x, and our line of symmetry is in the same place as the last graph that we just looked at, right? Just runs right down the middle of the graph right here, right? And you start to see the symmetry beyond or about this line. Okay, so if I were to kind of dot that, make a nice dotted line, we start to see that symmetry about that line. Right? And this has an equation of y equals x. And as it turns out, every single function and its inverse will have that same line of symmetry. Every inverse and its original graph will have a line of symmetry about y equals x. All right, so that's kind of important. Let's go ahead and build an input-output table for these. So I'm going to start with the original function, just 3 times x minus 2 cubed. So I'm going to go back to my calculator here, and let me get you that bigger view. There we go. Put that right here. And I'm going to go to y equals. I'm going to clear out all that stuff from the previous problem, and I'm just going to put in the original function, right? So we got 3 parentheses x minus 2 cubed. I'm going to raise that to the 3rd power. Hit enter. I'm not going to enter in the other one. It's too hard. All right, it's I should say it's too hard, but it's more work than I want to do. All right, so I really only need this function. And I'm going to do the same thing. I'm going to try and grab just like from, let's go from 0 to 4 here. Okay, so we'll say 0, 1, 2, 3, 4, and then we'll get some of those values that we had. So we had negative 24, negative 3. Oh, I want that big one there. And then we had 0, 3, 24. As you can see, I have horrible short-term memory. So now building the inverse table is really simple, right? If we use what we learned from our last function that we analyzed, we realize that these just kind of flip-flop, right? So I don't have to even put the inverse function into the calculator. I don't have to do any calculations. I can just take the original table that I have here and flip-flop those points and create my inverse table, right? So this is going to be 0, and then this will be 1, 2, 3, and 4. So there's my inverse table. All right. So I just wanted to show you how easy that is once you recognize that pattern between the original and the inverse table, and then also making sure that you can recognize this relationship on the graph. So we'll be testing you on those two things. All right. So make sure that you understand those two relationships. All right. We're going to do a little bit more with this tomorrow, but that's it for today. Good luck on the problems. Let me know if you have any questions in the Zoom chat.